I'm going to talk about factors and divisibility rules today. What I'm going to talk about here is very similar to what's on the homework. First thing it asks us to do is find the factors of 24. Okay. Now I'm going to demonstrate what they mean by that. The factors are two numbers that you multiply together to make a product. For example, 2 times 3 equals 6. These would be the factors, and this would be the product. Okay, and it's asking us for factor pairs. Now, factor pairs of 6 are, factor pairs of 6 would be 2 and 3. And another factor pair would be 6 and 1, because 2 times 3 is 6, 6 times 1 is 6. Okay, now we're going to do that for 24, and we're going to use our divisibility rules to help us. Now the first one that works for every number is 1. 1 times 24 is 24. And my factor pair would be these two factors that I'm multiplying together. That's my factor pair. So I'm just going to write it here. 1, 24. That's my factor pair. Now I'm going to go through this list and try all these different rules to see if 24 is divisible by any of these numbers. So, is 24 divisible by 2? Well, if the number is even, then it is divisible by 2. Is 24 even? Yes, it is. It ends in either 0, 2, 4, 6, or 8. It ends in 4, so it's divisible by 2. And if I were going to, so I need to figure out what I multiply by 2 to get 24, and if I don't know that immediately, I can just say, well, 24 divided by 2 is 12. So 2 times 12 is 24. So if you're not sure what this next digit would be, you would just take your original number, divide it by what fits the divisibility rule using long division, and you'll get this number, your other number in your factor pair. So my factor pair here is going to be 2 and 12. Okay, so next I'm going to see if it's divisible by 3. Now, here's how you tell if something's divisible by 3. You take all the digits in the number and add them together. And if the answer that you get is divisible by 3, then your original number is divisible by 3. And I'll demonstrate what I mean by that. Let's take 24. I'm going to add up the 2 and the 4. The 2 plus 4 equals 6. Now, is 6 divisible by 3? Well, yes, it is. Therefore, 24 is divisible by 3. This is a really useful trick, especially if you have really big numbers. You want to see if it's divisible by 3. You just add up all the digits. So what's divisible by 3? So 24 divided by 3 would be 8. So 3 times 8 is 24. And so my factor pair is 3 and 8. So next I try and see if it's divisible by 5. If a number ends in 0 or 5, it's divisible by 5. Well, 24 ends in 4, so it's not divisible by 5. Now, is 24 divisible by 6? Well, it's divisible by 6 if it's divisible by 2 and 3. Is 24 divisible by 2, and is it divisible by 3? Yes, it is, so it's divisible by 6. So 24 divided by 6 is 4, so 6 times 4 is 24. And my factor pair is 6 and 4. Okay? It only gave us the number of spaces that were needed, so I know that I'm done, but let's just see what this one says. If I wanted to check to see if it's divisible by 9, what I would do is add up all the digits just like I did before for my 3's rule, and if my answer is divisible by 9, then the original number is divisible by 9. Well, I already added them up and I got 6. Is 6 divisible by 9? No, it's not. So this is not divisible by 9. So I'm pretty much done, but you notice that some of the numbers are missing here. We're missing 4, 7, and 8. We're missing 4, 7, and 8. Well, the reason for that is because there are divisibility rules for 4, 7, and 8, but they're really only useful for really, really long numbers. The divisibility rules actually for these are actually a little bit complicated. And it's only really useful for numbers that are much larger than what we'll be dealing with. So in this case, for what we're doing in 5th grade, it's just faster to just divide them the old-fashioned way to check if they're divisible by 4, 7, and 8. So let's check 4. Well, we already know it's divisible by 4 because we already found it. And 8, we already know it's divisible by 8. Well, is 24 divisible by 7? Well, let's check. 24 divided by 7. 7 goes into 24 3 times. 3 times 7 is 21, and we get a remainder of 3, so it is not divisible by 7. So this is it. Now let's try 39. We start with 1, as always. We get 39. So my factor pair is 1 and 39. Now let's see if it's divisible by 2. Well, this is an odd number, so it's not divisible by 2. Let's see if it's divisible by 3. 9 plus 3 is 12, and 12 is divisible by 3. So 39 is divisible by 3. So let's divide 39 by 3. 3 goes into 3 one time. 3 goes into 9 3 times. And it goes in perfectly. So it's 3 times 13 is 39. And my factor pair is 3 and 13. Now, it's not 39 is not divisible by 5 because it does not end in 0 or 5. It is not divisible by 6 because it is not divisible by both 2 and 3. It's only divisible by 3, but it is not divisible by 2. Therefore, it's not divisible by 6. It has to be divisible by both of these to be divisible by 6 because 2 times 3 is 6. And it's not divisible by 9 because if I add 9 plus 3, I get 12. That's not divisible by 9. It's not divisible by 4 because if I were going to divide this, I would get a remainder of 3. I'm just doing it quickly, so but you can check that on your own if you want. It's not divisible by 7 because I would get a remainder of 4. It's not divisible by 8 because I would get a remainder of, let's see, of 7. All right. So now it asks us to list the factor pairs without giving us this handy chart. So we don't know exactly how many factor pairs there are going to be. So let's start with 56. 56, I know is going to be 1 times 56. We always start with 1. Now, is 56 divisible by 2? Well, yes, it is because 56 is an even number. So 2 times, well, I don't know how many times it goes in, so I'm going to do some long division. 2 goes into 5 2 times. 2 goes into 16 8 times, so it's 2 times 28. Now, is 56 divisible by 3? Well, 6 plus 5 is 11. So it's not divisible by 3. Is it divisible by 5? Well, 56 does not end in 0 or 5, so it's not divisible by 5. Is 56 divisible by 6? Well, it's not divisible by 3, so it's not divisible by 6. The nice thing about the 6 divisibility rule is if you're going through this list, all you have to do is look in here and see if you have a 2 and a 3, then it's divisible by 6. If you only have one of those, then it's not divisible by 6. And is 56 divisible by 9? Well, 6 plus 5 is 11. And that is not divisible by 9, so it's not divisible by 9. So now, so I've gone through this whole list and I found only two things. We need to check the ones that are not on the list, the ones that we don't have a special trick for. We still need to check them. So let's see if 56 is divisible by 4. I'm just going to do long division. 4 goes into 5 one time. 4 goes into 16 4 times. So now I have 4 times 16. So 4 and 16 are another factor pair. Now let's try 7. 56 divided by 7 is actually 8, because 8 times 7 is 56. So I have 7 times 8. And I don't need to try 8 because I just found it here. So 56 actually has 4 factor pairs. So I'm going to write them here. One, you can either write them like this, or you can put a comma in between them, but you need to separate them out like this so that you can tell which ones are factor pairs. And 7 and 8. So my factor pairs are 1 and 56, 2 and 28, 4 and 16, and 7 and 8. I got them from here. Okay. So one last one, we're going to do 64. Well, 1 times 64, of course, we always start with 1. Let's see if 64 is divisible by 2. Well, it is because, because 64 is an even number. So 2 times, now 64 divided by 2 is going to be 32. So it's 2 times 32. Let's see if 64 is divisible by 3. Well, 6 plus 4 is 10. And that, because I added up the digits of 64, 6 plus 4 is 10. That's not divisible by 3. And 64 does not end in 0 or 5, so it's not divisible by 5. And it's not divisible by 6. I can tell immediately because it's not divisible by 3. It's only divisible by 2. So it's not divisible by 6. And it's not divisible by 9 because 6 plus 4 is 10, and that's not divisible by 9. Now I need to check my numbers that are not on this list. Is 64 divisible by 4? Well, let's check. 4 goes into 6 1 time. 4 goes into 24 6 times. So 4 times 16 is a factor pair of 64. Well, let's try 7. 7 goes into 64 9 times, and I get a remainder of 1, so it's not divisible by 7. And let's try 8. 64 goes into 8 8 times. Exactly, so it's 8 times 8 is another factor pair. So I have 1 and 64, 2 and 32, 4 and 16, and 8 and 8. And those are my factor pairs for 64.